Well, thanks for joining midday, at least here in the Western Hemisphere. I just wanted to kind of start a program where we could talk about things that are going on with OpenNMS because it's so hard for everybody to keep up with everything. And I thought we could also, I'm going to try and screen record this and maybe share it out with the community later. We're all here in North Carolina sitting here eating pizza. I don't know what everybody else is doing. I'm just going to quickly go over some changes that's been done for Horizon 23 with respect to how alarms are managed or how alarms are representing problems in your network. And the basic concept is to use a single alarm to track the state of a problem rather than what we've been doing in the past, 12 years with two alarms. So, first thing, I'll probably talk a little bit about how alarms became the way they were in OpenNMS and that legacy problem state tracking. Then we'll move on to how we're doing it with a single alarm, and then if you guys have any questions, we'll do that. So in the beginning, there were just events, and that's why events have severities. So any message that happens on the event bus is basically just a queue that you can subscribe for different UEIs, and whether it's a message in the system to say restart a service or whether it's a message in the system about a trap that's come into the system, it's just an event. So what we did probably somewhere around 2006, I think, is we decided to create a behavior where messages could be identified as problems in the network, and we called them alarms. We kind of followed a paradigm that Netcool had been using, where you were using two rows in your alarm table to represent the current problem and do pairwise correlation, and that's kind of carried all the way through till today. It was a little redundant, even though we had to, because we always have had the representing events as well. And then it also used that same paradigm that Netcool Omnibus had for using SQL statements to do escalations and correlations with the alarms. So in the legacy way of doing things, you'll all be familiar with this. This is just an SNMP outage detected on my system, and I got an alarm. The count is 1, and then when the problem is resolved, or I get another alarm that says the problem has been restored, and that via an automation clears the previous problem. Eventually a garbage collection automation will run and remove this, but you can see if the problem happens again, the previous, if it's still in the active alarm list, it will now have a count of 2. It gets reset to its original severity, and then when it is restored again, then you can see also the resolving alarm gets its count incremented and clears the incremented problem alarm as well. You can always go back and click on the counts and look at the list of events that caused this to happen. So the alarm data on the events is what annotates these things to become alarms. This was just I just wanted to capture this for posterity, because in 23 this goes away as well, because we've introduced the Drools engine to handle these business rules, or this logic. And you can see here in the automation called Cosmic Clear, which was the pairwise correlation that we had, we would have a trigger that would go look for any alarms that were of a problem type that had matching clear keys in alarms that had resolving types. And it would match that clear key to the reduction key. And we did that in the automation phase of this alarm problem management. Now what we do is we do the same thing, but we do it with code, and it happens within alarm D. It takes a clear key and automatically reduces it and sets it into the same alarm, but we'll see that here in a minute. So again, the automations are now Drools rules, and we'll probably use that for the subject of another lunch and learn. It might be a long one.
Bring your working memory.
Exactly. Nice pun, Jeff. There's also now been introduced some properties for Alarm B where Alarm B had none before, and we're using a single alarm to track, represent the state of a problem in the network. No automation or Drools required for the pairwise correlation. So you can see here, we have a property set to go back to the old 2-alarm state. So you can come back and set this to true if you want to go back to doing the way things were. There's also another property that's been introduced that we'll talk about at the end of this, but if you set this to true, then that nullifies this property. Okay, again, now the same problem with the single alarm state. Now we're in a down. This is the initial alarm, and you can see that the same alarm, which was alarm number 69, is the same alarm that's cleared, and the count is still 1, because the problem only happened once, even though there were 2 events that caused this problem. So when it reoccurs, if the alarm is still in the active alarm list, then it will increment the count, reset the severity, and when it clears again, the count is not incremented, but it does update the log message. Again, on the clear, it does update the log message, and it does set the problem type to 2 so that we know that it's in a cleared state. And that was the last thing that happened. Oops, wrong way. Again, there's been 4 events carrying this alarm around the system, and there's only been 2 counts of this problem. Also, something that one of our customers asked for was if there is an existing problem that's been cleared, never let this happen where the count becomes 2. So when it happens, what you can do is you can set this new if cleared problem is this, you can set this to true, and I should have probably done that in the slide. Okay. And then now what will happen is when the problem comes in, you'll still get this same behavior with, you can see where 163, alarm 163 gets cleared, but when it happens again, it now creates a new alarm to track the problem as a different alarm, and it does that by altering the reduction key of the previous alarm, adding just something to the end to make it unique, which is a literal called ID, colon, and then followed by the alarm ID.
That's not there by default? Or it
It's
is?
not by default.
So only when the successor alarm is created, it alters its predecessor alarm?
And only when this property is set to true.
Right.
And again, if you turn this single alarm handling off, then this gets defaulted to false. You can't use this feature with the 2 alarm. I couldn't find a way to make that work very well. If we had persisted the clear key with the resolving alarm, I could have done it. And I think that's pretty much it. Again, when it happens again and clears, it now clears that one. And subject to your questions, that completes my demonstration of new alarms in OpenNMS.